In this episode, we're going to look at how to troubleshoot default gateway issues. I'll show you how to do it and have a discussion of the topics along the way. For a device to communicate across multiple networks, it must be configured with an IP address, a subnet mask, and a default gateway. The default gateway is used when the host wants to send a packet to another device on another network. The default gateway address is generally the address of the router interface, which is attached to the local network that the host is connected to. In this activity, we're going to finish documenting the networks. We'll then verify the network documentation by testing end-to-end connectivity and troubleshoot issues. The troubleshooting method we'll use consists of the following steps: verifying the network documentation and use tests to isolate problems. Next, determine an appropriate solution for a given problem. Third, implement the solution. Fourth, test and verify the problem is resolved. And then finally, document the solution. Throughout our CCNA studies, we'll encounter different descriptions of troubleshooting method as well as different ways to test and document issues and solutions. This is the intention. There is no set standard or template for troubleshooting. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Troubleshoot default gateway issues. I got my labs opened up here. Once again, on my left side, I have the packet tracer lab that has the topology. That's what we'll be doing all the activities for this lab. On the right side, I have, on the top right, a Word document of the instructions. On the bottom right, I have the packet tracer activity window that opens up. I use the Word document so I can go and fill in all my answers. Here we have the addressing table. This is the addressing of all of our devices. Notice here that they don't give us the default gateways. Default gateways aren't given to us on purpose because we have to go and we have to figure out those and correct those in this lab. The topology on the left side, notice I have it opened up. It's been open for a couple minutes now. All the triangles are green, meaning all the connections are good. They went through the auto negotiation process. All the protocols are up. It's good. But there's a chance some of these might be misconfigured. And what we have to do is go in here and look to see what's been misfigured. Two objectives. Background here. For a device to communicate across multiple networks must be configured with an IP address, subnet mask, and the default gateway. And once again, that default gateway is the exit off of our network onto other people's networks. And if that's set incorrectly, we won't be able to communicate with anybody else off of our network. And what we're going to have to do is go through and verify the network documentation. We're going to have to create our own network documentation to make sure we have communication with all the devices on there. And how we're going to do that is we're going to ping, and we're going to go through a troubleshooting process to help us figure that out. The process we're going to use right here is step A. We're going to verify the network documentation and use tests to isolate the problems. We're going to document, we're going to write it down. That's one of the big things in troubleshooting, is writing it down so you can keep track of what you're doing. We're going to use some tests to figure out what the problems are. B, we're going to determine an appropriate solution for the problem. So based upon our isolation of the problems, what are we going to do to fix it? We're going to go through, implement that solution. We're going to test the problem has been resolved, and then we're going to document that solution. Once again, this is a big deal because as we go through our networking tools and going forward, you're going to have to do this a lot. And the troubleshooting here could be as simple as inverting a number or putting in a wrong default gateway to have that communication not work. Instructions, part 1. Complete the documentation and perform connectivity tests to discover issues. In addition, you will determine an appropriate solution for the implementation in part 2. Once again, we're going to figure out what the problems are and then figure out what our solutions is and go ahead and implement that. Where we can effectively address effectively test the network, you must have complete documentation. Notice the documentation, some of the information is missing. Complete the address table by filling in the missing default gateway information for the switches and PCs. Test connectivity issues by the same way. Take care of step 1A, going up here and filling in our default gateways. Looking here, switch 1 right here is on the 192.168.10 network. Now, the default gateway for switch 1 or any of these PCs, PC1 or PC2, is the exit off of our network onto another one. Typically, that's a router. And what we're looking for is this connection right here. This connection right here on one is our default gateway. If we mouse over here, we can see that it's gig 00 it's plugged into. Then I'm going to mouse over R1 itself, and there it's going to say gig 00, and that's the top line there. That IP address is 192.168.10.1. Now, to have that be a true default gateway, it needs to match the first part of our IP address. It needs to match where our subnet mask says it's the network portion. Where there's all ones or 255s in there, the first 3 octets, that is our network portion. And what we came up with was our default gateway of 192.168.10.1. Once again, notice that that is the first 3 octets are the same. That is part of our documentation. Switch 2. Once again, switch 2, the exit is on and off here. If I mouse over, I got to click in the window. If I mouse over this triangle, it tells me I'm looking at gig 01. Mouse over the router itself. Gig 01 gives me an IP address, and that's the second line down there of 192.168.11.1. That is my default gateway. 192.168.11.1. PC1 and PC2 here, they go through switch 1, but remember, switches don't connect up multiple networks. They just connect all the devices on your local area network. What we need here, once again, is this port way down here, this interface. Mouse over the triangle here. Once again, it reminds us that we're looking at gig 00 is this connection. Mouse over router 1, and it tells us gig 00. Sorry if I said that wrong earlier, but we're looking at gig 00 is 192.168.10.1. And yes, that is the same default gateway as switch 1. 192.168.10.1. And that was the same for PC2. Then looking at PC3 and 4, once again, our default gateway is not on the switch, it's on this router. It's this interface here. Okay, if we mouse over the triangle right here, leading from PC3 to PC4, it'll tell us that what we're looking for right here on this connection is gig 01. Now, to find out what the IP address on gig 01 here in Packet Tracer, I just mouse over the router here. It'll give us a little pop-up menu, and we'll look for gig 01 there. That's the second one down. The IP address is 192.168.11.1. That's our exit off of this network onto other networks. And yes, it's also the default gateway of switch 2. 192.168.11.1. 192.168.11.1. So there we go. We figured out what our default gateways are supposed to be. We finished that documentation there. Now we can go back down to part 1, step 1, part B. Test connectivity devices on the same network by isolating and correcting any local issues you have. You can better test remote connectivity. And what they're doing is having you test the closest stuff first. And I believe this is the true way to do troubleshooting. You start and you troubleshoot the connections closest to you. And then we want to document that. Now down here, what we want to do, and this is just an example here, we're not going to jump into that one right away. What I want you to do is start pinging your own devices. And we're going to work on the top network first. We're going to work on being able to ping ourselves. So PC1, we're going to try and ping our own IP address. PC2, switch 1, we're going to ping our own IP addresses. And so the test here is PC1 ping self, PC2 ping self, switch 1 ping self. And we're going to go through and we're going to just open up each one of those ping, and that's as close as you possibly can get to yourself to ping and start troubleshooting. Now, if those don't work, that means the IP address is set wrong for some reason. I'm going to go over here, click on PC1, opens that up. I'm going to click on the desktop tab and then open up the command prompt, because ping is a command prompt tool on a PC. I'm going to go in and type in ping and then the IP address of PC1. Now, this is where keeping both of these windows open kind of helps. And as you can see right here, I can see what PC1's IP address is, 192.168.10.10. 192.168.10.10. Okay, so I can't even ping myself. Once again, we start as close as possible. Was I able to ping myself? No. I'm going to go through and ping the other devices here quick. I'm going to go ahead and click on PC2, desktop tab, open the command prompt, and I'm going to put in ping, and I can get the IP address for PC2 right here. 192.168.10. Oops. 192.168.10.11. And see how this one worked just fine. I was able to ping myself successfully. Answer yes there. I'm going to go ahead and minimize that. I'm going to open up S1 here. Now on the router iOS, we have to go into the CLI. We have to go into PuTTY. We have to go in using our console connection. I usually make this window a little bit bigger. Press return to get started. Enable to get us into privileged exec mode to allow us to do ping. And then ping, once again, you can get your IP address and switch one right here. 192.168.10.2. Successfully worked. And so what we have to do, we'll fill in the chart here. What we have to do is go back and figure out, why did PC1 not work? Well, let's open that up. One of the commands you're going to use here is called ipconfig, all one word, all lowercase. And this works on Windows boxes in the command prompt. What it's going to do is give us some information. Right here, this is our fast Ethernet connection. That's what we're connected to. And then it's going to list our IP address. Our IP address for PC1, 192.168.11.10. But if we go and we look here, down here, our IP address should be 10.10 at the end. We have to go in and change that. Looking here, we have to close the command prompt. We go ahead and close that. We're still on the desktop tab. Now we have to go into the IP configuration tab. Right here, we list out that we're on our fast Ethernet, we have a static IP address, and then this is where we have a wrong IP address. Also, even if we look here, we can see that the IP address, well, looking at the subnet mask, the first 3 octets are the network portion. If we look at the IP address, it's 192.168.11, and our default gateway is 192.168.10. So a .10 and a .11. They are technically separate different networks. they are not even able to communicate with each other. So we need to make them both on the same network. We can do that by correcting the IP address here for PC1, changing it to .10. All you got to do is enter it. We can go ahead and close the IP configuration window. Still on the desktop tab, we're going to open up the command prompt again and enter a couple times. And let's ping our own IP address. Once again, the IP address here is 192.168.10.10. And there we go. We can now correct it out. What was the issue here? IP address was wrong. Changed it. Actually, we'll say corrected it. And yes, we just did verify that it worked. Excellent. So we're able to ping all of ourselves here. Well, next step I'm going to do is go from PC1 to switch 1, PC2 to switch 2. PC1 to switch 1, PC2 to switch 1. I'm going to go ahead and ping those. Once again, open this up. My command prompt is still open. Ping, and we're going from PC1 to switch 1. Switch 1's IP address is right here, 192.168.10.2. A requested timeout, but it worked on the second, third, and fourth time. Once again, what happened was it had to go through the ARP lookup. It had to find the MAC address for the IP address we were pinging. Once we did that, we were able to complete it. Now, if I repeat this again, all 4 times should work. Once again, up arrow is our friend. Go ahead, ping it, and there it is. It's working just fine. That was able to work. Oops. Yes. Minimize that. Open up PC2. I'm going to ping that same IP address because it's switch 1, 192.168.10.2. Hopefully we're just doing a ARP lookup. There we go. 3 times it works. If I repeat it again, we get all 4 times successful. Excellent. So yes, they did work. Now, we're able to ping there. We're assuming that if we ping, and once again, remember, a ping is an echo request and an echo reply. If we ping a device and it works successfully, we're assuming that's the other direction will work. So we were able to ping PC1 to switch 1. So echo reply from PC1 to switch 1, and then echo reply from switch 2 back. We don't have to ping the other direction. We can assume that works. Now, let's go and take this a step forward. Let's take all 3 of these devices and ping our default gateway to see if that works. PC1 to default gateway. PC2 to default gateway. And switch 1 to default gateway. Once again, our default gateway, if we mouse, I clicked in the window, I'm going to mouse over this triangle. It says it's gig 00. I'm going to go ahead and mouse over R1 here. It's going to pop up a window. Gig 00 has an IP address of 192.168.10.1. All 3 of those devices, PC1, PC2, switch 1, have that as their default gateway. So that's what we're going to ping. Open up PC1. Ping 192.168.10.1. There we go. PC1 successful. ping 192.168.10.1. That is successful. And switch 1. Ping 192.168.10.1. There we go. We had to do an ARP lookup. That's why we only had 4 out of 5 work that time. If we do repeat that process, up arrow's our friend. All 5 will work. Go over here, update our chart. All 5 of those, or sorry, all 3 of those worked at that point in time. We checked our local connectivity for this top network, for the 192.168.10 network. We're going to check our connectivity for the bottom network. We're going to do the same process. We're going to have PC3, PC4, switch 2 ping itself. And we're going to have it ping the other devices. And then we'll have it ping their default gateway. Go ahead and click on PC3 at this point in time. Go to desktop, go to command prompt. Ping, and then the IP address for PC3 is right here, 192.168.11.10. Ping 192.168.11.10. You got to put the word ping in there once. There we go. Pinging myself for PC3, that worked. Go ahead and try PC4 right away. Command prompt. Ping 192.168.11. Once again, IP address for itself, PC4, right there. 11.11. There we go. PC4 is able to ping themselves. And let's try switch 2. Over there, I automatically make the window a little bit bigger. Press enter, get into privileged exec mode by typing enable. There's no password set at this point in time. We have enabled it. And we can ping ourselves, ping space, switch 2 IP address is one right here, 192.168.11.2. 192.168.11.2. Oh, Scooby-Doo. Didn't work. Okay. What we're gonna do here is say PC3 ping self. PC4 ping self. S2 in self. Again, remember PC3, PC4, they both worked. Switch 2 did not. So we're gonna have to figure out what's wrong. What I would do is I would look at my configuration, how my device is configured right now. I would look and see what is in RAM. The command to do that once again is what? Show run. Go space running dash config is the long way. Go ahead and hit enter. I space bar down through it a couple of times. And then I scroll back up here. Now, we're setting an IP address. We don't set it to the interfaces. What we do is we set it to interface VLAN 1. We set it right there. And so we have to go in and we have to configure that. Just like we've done in our previous exercise. We go into global configuration mode, config T. Then we have to go into that interface itself. So interface VLAN 1. Then we're going to have to set the IP address. Once again, the IP address here is 192.168.11.2. Command P IP space address 192.168.11.2. And then we also have to make sure we put the subnet mask in there, which is right to the right of that down here. Right here we see this is our subnet mask. 255.255.0. And the other thing we need to do with that is turn that on. Once again, the command to turn it on is the opposite of to turn it off. The command to turn it off is shutdown. The command to turn it back on, you put the word no in front of that. So it's no shutdown. So no space shutdown. Exit out. Exit out. We'll give you an update. If we do a show run again, we will see, I do spaces all the way down. We will see that our IP address here is now set to 11.2. If we ping that, there you go. It worked fine. And so what happened was IP address wasn't set. So we set the IP address and then we confirmed it. Here we go. Now that was pinging ourselves. What we're going to do now is the two PCs are going to ping switch 2 to verify that's going to work. And so PC3 to S2 and PC4 to S2. S2's address right here we just set. And so the PC should be able to see them. So I'll go ahead and open up command prompt on ping or on PC3. Ping 192.168.11.2. Hopefully we're doing an ARP lookup here. There it is. We got 3 out of 4. We had to do that address resolution protocol. We knew what the IP address we were pinging, but because it was on the same network, we were going to use the layer 2 address, the MAC address, so we had to figure that out. That's what the ARP process did. If we do the ping command again, up arrow is your friend, all 4 are going to work. There we go. PC3 to S1 works. We are also going to go from PC4 to switch 2, 192.168.11.2. Hopefully we're doing that ARP process again. Going to fail on the first one, but the next 3 are going to work. There we go. Next 3 work. Just to verify it, up arrow once to repeat that ping command. There we go. All 4 worked. Able to get that to work. Now, there is one more I have to do on the top network that I forgot to do. We'll do that on the bottom network. But it's pinging PC1 to PC2 and PC3 to PC4. Making sure that that works. And so PC1 to PC2 and PC3 to PC4. Going to open up PC3 here. PC4's address right here is 11.11 at the end. 192.168.11.11. There we go. That worked from PC3 to PC4. I'm going to minimize that. I'm going to open up PC1 and I'm going to try that ping also. So we're on PC1. We're going to ping PC2 at that point in time. 192.168.10.11. And there we go. PC1 to PC2, both of those worked. Okay, going back down to the last one, or to the bottom half again. Now we're going to take these 3 devices, PC3, PC4, switch 2, and then ping our default gateway. PC3 to default gateway, PC4 to default gateway, and switch 2 to default gateway. Now our default gateway, once again, is the exit off of our network. That's this connection on this router. If I mouse over this green triangle, and I did click in the window, it tells us we're looking at gig 01. I go ahead and move the mouse up here to R1. R1 is going to say, if you look at the second interface down, gig 01, that IP address is 192.168.11.1. That is our default gateway for any device on that bottom network. All three of those devices will ping that same IP address. Going over to PC3. Clicking in the window. Ping 192.168.11.1. Here we go. PC3 to default gateway. That did work. PC4. 92.168.11.1, pinging our default gateway. PC4 to the default gateway. That did work also. Updated my chart. Minimize this. Going to switch 2. Ping 192.168.11.1, our default gateway again. There we go. Notice it only worked 4 out of 5 times. It had to go through the address resolution protocol the first time to figure out what the MAC address was. If we repeat that command again, up arrow's our friend. Go ahead, all 5 will work. Now, what we've done is all of our local devices can ping each other, ping all the other devices in our local area network, including our default gateway. For the top network, for the bottom network. Now we're going to try and go across the router. What we're going to do is we're going to go PC1 and we're going to try and ping switch 2. And PC1, we're going to try and ping PC3 and PC4. PC1 to S2, PC1 to PC3, and PC1 to PC4. That's what we're doing here. Okay, click on PC1. Ping the IP address for switch 2. 92.168.11.2. It's on a different network because our network portions the same or different. 92.168.11.2. There we go. We are able to successfully ping that. We're able to go from PC1 all the way through S1 to R1, change networks, and ping PC2, and then the echo reply was able to come all the way back. That is looking good. Now let's go ahead. Update my chart here. We're going to go PC1 to PC3. Ping, then PC3's address right here. 192.168.11.10. We are able to successfully do that. Let's try and ping PC4.11.11. I up arrowed once, backspace, change it to .11 at the end. There we go. Uh-oh. .11 is not working. So we need to figure that out. Why isn't that working? Step 4 didn't come back. There was an issue with it. Now let's think about this. PC1 was able to go all the way through S1 to R1 to S2 to PC3. So it's able to get all the way to switch 2, but then it's not able to get to switch or PC4. The problem lies somewhere in here. But PC4 was able to get to switch 2. PC4 was able to get to R1. Maybe it's the configuration here on PC4. Let's take a look at that. Once again, one of the troubleshooting commands you're going to use is ipconfig. That's a command prompt inside of Windows, all one word, all lowercase. Go ahead and look at that. Here is our information. Our IP address, 192.168.11.1. Our default gateway looks a little bit odd. If we scroll up and look at our chart here, for PC4, it should be 11.1, not 1.1. So we have to go in, we have to change that to match what we calculated. Right now, it's 1.1, which is not on our network. Our network here is the 192.168.11 network. If we look here, it's 192.168.1. They're on two different networks. We need to make the default gateway correct. In the PC4 window on the desktop tab, I'm going to go ahead and close the command prompt. You can do that by at the end of this right side of this blue line. Go ahead and click the X. Now we can click on IP configuration. If we look in here, this is where our IP address is wrong. We need to change in that third octet from .1 to .11. If I go ahead and do that, I can close the IP configuration. It's at the right of the blue line. Open up my command prompt. And that's not what we're fixing. Remember what we're testing. This is where our documentation is important. We're testing PC1 to PC4. So I'm going to minimize that, open up PC1, and I'm going to ping PC4, which here again is 192.168.11.11. And it's working. Now we're going to need to fill in the chart. PC4 default gateway wrong. Corrected. Default gateway, and then we verified it worked. It was able to work at that point in time. PC2, we're going to do the same thing as these right here. We're going to ping, because we were able to ping all the way up to our router. Now we're going to have to ping switch to PC3 and PC4. Make sure that all works. PC2 to S2, PC2 to PC3, and finally PC2 to PC4. Open up PC2, type in your ping command. For S2, our IP address, once again, we can get that off of our chart right here. 192.168.11.2. That successfully works. Next one, ping. And then we're looking at PC3. This IP address, 11.10 at the end. There we go, that one works. And PC2 to PC4. PC4's address is right here. 192.168.11.11. And there we go. That works. And the last step we have to do, because once again we have the echo request and the echo reply here, we need to have switch 1 ping both switch 2, PC3, and PC4. Switch 1 to switch 2, switch 1 to PC3, and switch 1 to PC4. Open up switch 1. We have our command prompt. Oh, we were automatically logged out. You need to get into use your privilege exec mode, type enable, and then we can start our ping commands. Pinging. We're going from S1 to S2. S2's IP address right here is 192.168.11.2. Oh, switch 1 isn't working here. Let's go in and see what is wrong. Now we're going to see what our configuration is. Do a show run here. I spacebar all the way down, and I come back and I look. Okay, we have our host name. We have our interfaces. We don't have nothing configured there. Interface VLAN 1 is right here, but we do not have a default gateway listed anywhere. If you look once again, there is no IP default gateway listed, so it doesn't know where to send the information to get off of the network. We need to go in and configure that. Get into global configuration mode. Config T. Config T. There we go. We're in there. Command here is IP space, and then we can put a question mark. Does any of these look familiar? What we're doing? Default gateway. Specify default gateway. So DEF, I use tab to complete it, put in a question mark, let us know what it's looking for. Now it's looking for our actual default gateway. If we scroll up to the chart we completed at the top here, we can see that on switch 1, our default gateway is 192.168.10.1. 192.168.10.1. Exit out. There we go. And now we can go down and try to ping what just failed. So S1, S2, that failed. No DG specified. Set our default gateway. And let's confirm it. Let's verify it works. So ping, and we are pinging switch 1 to switch 2. Switch 2 IP address right here, 192.168.11.2. There we go. 5 out of 5 successfully pinged. We are able to fix that. We verified it worked. Okay, last couple steps. Ping from switch 1 to PC3. PC3's address right here, 192.168.11.10. 5 out of 5. And finally ping PC4. PC4's IP address is right there, 192.168.11.11. Successfully works. All successfully worked. If we look here, we came up, there was 4 problems. Right here, PC1 had the wrong IP address. Switch 2 didn't have an IP address set. PC4 had the wrong default gateway. And switch 1 did not have the default gateway. No default gateway on S1 specified. There we go. We tested the connectivities, we did all that, we documented our problems, we looked for remote processes. After you solve those issues, return to this step. And a lot of times what people will do is find a problem and fix it and work on it. Try and get in the habit of starting and pinging the closest you can and then working your way out. If we look here, we started with ping 1, we pinged our own IP address. Then we pinged switch 1, then we pinged R1, then we pinged switch 2, then we ping PC3 and PC4. We worked our way out further and further. As we take care of the problems, the system will start working. Implement and verify our solutions. In part 2 of this activity, you'll implement the solutions you identified, and then you'll verify them. Actually, that's what we did. We went through there, we worked on it. Step 2, verify a solution has been solved by performing a test you can use to identify the problem. For example, can PC1 now ping PC2? And yeah, what didn't work, we identified the problem, we fixed it, and then we tried it again and it worked. Verify all issues have been resolved. We went through there, all of them done. If we look here, Remember, if you ping a device, they have to send you back a reply. And so that takes care of both directions. As we worked through this process, we tried every one of these possible combinations going one way. And if you continue to look, any of the other ones that were remaining was covered when we did the one way or the second reply on that echo request. We essentially pinged all devices on that network and showed everything worked successfully. That is the end of Packet Tracer Lab 10.3.5 Troubleshoot Default Gateway Issues. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.